Oceans, rivers, and lakes cover 75% of the planet. Poor land use management, population growth, increasing standard of living, climate change, industrialization, agriculture, and urbanization led to decrease the availability of clean water. Additionally, surface and groundwater are polluted by many wastes such as industrial water discharge, salt water intrusion, soil erosion, inadequate sanitation, contamination of ground surface waters by algal blooms, detergents, fertilizers, chemicals, and heavy metals. Limited possibility of an increase in the supply of fresh water due to population growth through the world. Also, water-related problems are expected to increase further over the next 2 decades. A significant saving of potable water can be achieved through reuse of wastewater, which in turn requires the development of materials and methods which are efficient, cost-effective, and reliable. Polluted water has to go through several treatment processes before it can go for industrial and domestic purposes. The typical treatment of water consists of coagulation, sedimentation, filtration, and disinfection process. The major role in the treatment of water, wastewater, and in the disposal of sludge is played by wastewater treatment agents. Many inorganic chemicals and organic, such as synthetic polyelectrolytes or plant origin materials, are used as coagulants, flocculants in conventional treatment process. Treatment residues may cause several health hazards.
Inorganic coagulants have high poisoning factor. Moreover, the typical synthetic polyelectrolytes are also toxic and carcinogenic. Due to those issues, there is a strong need in replacement of inorganic and organic coagulants with alternative natural coagulants, flocculants, or health-friendly synthetic wastewater treatment agents. The great interest in those products is due to their environmental friendly behavior, safe to human health, and relatively low cost.
Natural polyelectrolytes have been used for many centuries in developing countries for purification of water. The wide variety and accessibility, abundant source, as well as low-cost biodegradation, characterized with environmental friendly behavior and presumed to be safe for human health, make plant-based polyelectrolytes the most attractive coagulants and flocculant sources. Tannins are widely distributed in leaves, wood, bark, fruits, roots, and seeds. They are cationized by Marie-Curie reaction, which leads to obtain new coagulants for removal of anionic contaminants. Derivatization of cellulose from industrial cellulosic wastes by introduction of anionic or cationic groups in the cellulose backbone led to produce eco-friendly flocculation agents. For wastewater treatment, including the coloration of effluents from, for example, textile industries.
Acrylamide-based polymers designed specifically to treat oily wastewaters from food industry are developed using health-friendly formulations. The reagents used are non-irritating with high boiling point, high stability and high purity, free of harmful ingredients, color, odor or taste. They differ by their chemical composition and they are of high interest in industry due to their physical properties and level of purity. The structure of polyelectrolytes and their surprising, unexpected physico-chemical properties allow to create, in many cases, completely new applications. It is exactly what may happen in the case of our new developed polyelectrolytes. They can find application in several different sectors, starting from environment, food, cosmetics, pharmacy, paper making, and much more. However, their selection will require extensive pilot trials.